Alright, our third example asks us to find the ratio of x to y if 3x equals 4y. So basically we're just going to set up the proportion, but we need to make sure that it's set up correctly. So I want to go back to the intro video where we said that using the means and extremes. So if you remember, the way we set up a proportion with our means and extremes is first you have extreme over mean is equal to mean over extreme. And then we were told that if you multiply the extremes, it's equal to the product or multiplying of the means. So what we have here is we've multiplied the extremes and we've multiplied the means. So I'm going to say that 3 and x are the extremes and 4 and y are the means. And when we set this up, we want the 3 and the x to go in the extreme spot, and we want the 4y to go in the means spot. So the only thing we want to be careful of is where we're setting everything up. You know, if I know that 3x have to go in the extremes, I have to put either a 3 or the x here or a 3 or the x here. And what I'm going to look at now is that it says find the ratio of x to y. So if you were to set up that ratio, you would say x over y. So I want to make sure that one of these ratios is x over y. So first, let's look at the extremes, 3 and x. So I have to put the 3 here or the x here, and then the other one goes down here. And following what we just said, I want to go ahead and put the x on top and the 3 on the bottom. And that, if that got multiplied, that'd give us our 3x right there. Now I need the 4 and the y to go in the mean spot. But I'm looking at this ratio, I can see that I want the y right there below the x. So I want the y to go there, which means the 4 has to go on top. So we have our extremes and our means, and if you were to multiply those, you would get this statement right there, 3x is equal to 4y, and we just had to look at this part of the question, ratio of x to y, so that we knew where each piece went.